The topic of today's webinar is deploying a web application to the cloud using Terraform and Packer. To present this topic, we have with us Mr. Loban Rahman, joining us from Vancouver, Canada. Loban is the co-founder and CTO of Quantigo AI and has more than 15 years of experience at all stages of software development. So welcome, Mr. Loban. And we also have with us Mr. Asanul Choudhury, also joining from Ontario, Canada. And Asanul has more than 40 years of experience as a professional software engineering. So please welcome Mr. Asanul and Loban.
Thank you very much. Thank you all of you for welcoming me to this forum and giving me this opportunity to give my presentation on this topic. Welcome everyone to my humble presentation on deploying a web application to the cloud using Terraform and Packer. I'm Loban Rahman. I've been in the industry for the last 15 years in various forms and facets, starting as everyone does as a software engineer, I've worked as an architect, an analyst, and right now I am the CTO of Quantigo AI. If you'd like to know more about Quantigo AI, you can come to our website. What we do is provide training data and other resources to companies and individuals who want to train and create machine learning models. If you would like to learn more about me, you can visit my LinkedIn profile or my GitHub profile. But that's enough of me. Let's start with the presentation. Before I go deep into the topic, I want to do a little bit of revision with everyone here. What is a web application? What are the major steps to launch a web application? Let's do a quick revision. I mean, this is going to be something we all know, but I feel I would like to highlight a few points here because we're going to visit them over and over again during the course of my presentation. What do you do when you want to launch a web application? I mean, first of all, you develop it, right? We need to create a hosting environment. We need to deploy the web application to the hosting environment, and then we need to maintain it. Now, I'm sure all of you present have seen seminars on the very first topic, developing web application. There's lots of resources on frameworks to use, tools to use, languages, tools, and techniques, and so on. But my presentation today is going to focus on topic number 2, creating a hosting environment, and topic 3, deploying your web app to this hosting environment. And we'll be looking at different ways this has been done through over the years. And I'm hoping to introduce all of you to a few tools that are part of my day-to-day activities when it comes to these particular stages. All right. So traditionally, when we want to host a web application, what are the resources that we need? Now, let's go through them really quickly over here. First of all, we need some server resources. What does that mean? We have some hardware, CPU, RAM, hard disks, storage, basically, usual stuff. We need an operating system. We need some software libraries, and obviously we need an internet connection configured and set up such that people can access our application on this server. Really simple stuff. And in addition, with server resources, we need network resources. What are those? Let's look at the very basics. We need an IP address, a real one that people can access, a public IP address that people can access. Ideally, you want a domain name. You don't want people access to a web application with an IP address. In order for that to work, you need a DNS entry, connecting the domain name to the IP address of your server. All right. What do we do traditionally when we want to deploy our web application to this hosting environment? Very, very quick visit. The most basic form, which people are still doing now, is FTPing to our web server that has been previously set up. Or a more advanced form is to SSH in and maybe use Git, SVN, or whatever source code management software you're using to pull it from a repository into the application server. Okay, so quick summary over here. These are the things we need to host a web application. Server, resource, network. It's very simple, but please keep these terms in your head because we're going to visit them a couple of times. And my goal for this presentation, at the end of this presentation, I would like all of you to look at this a bit differently than the way perhaps you do now. To do that, we're going to go to the next topic over here, cloud computing. What exactly is cloud computing? Let's look at a definition I picked up from the web over here. Oops. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet, also the cloud, to offer faster innovation, flexible resources, and economies of scale. That's a mouthful and a lot of buzzwords, but let's focus on a couple of things over here. Notice these two words in over here, servers and networking. We just talked about this. These are the two resources that we traditionally think about in very basic terms when you want to host a web application. We need some server resources and we need some networking resources. And traditionally, how would we have done them? We would have set them up as we discussed physically. You know, we have a physical server, we set up the operating system, and we configure it, put the application in it. However, cloud computing is saying that we don't need to do that anymore. We can access all of this infrastructure over the internet in a much faster and flexible way. So, I mean, what are some examples of these? If you haven't heard of these terms yet, you ought to have, I must say. I mean, at the very least, I'm sure you've heard of Amazon Web Services, and there's also Google Cloud Platform and Microsoft Azure. The biggest granddaddy of them is Amazon Web Services, and so we'll focus mostly on that today when talking about cloud providers and cloud computing. Going back to this page, what are the things we need to host a web application? And how does this translate to now using cloud computing rather than physical infrastructure? This is when I'm going to jump to a live demo over here. And we're going to go directly to AWS Web Service to take a quick look at what this is. Once you log into AWS Web Services, you'll see that there's many different services available over here. We don't need to go deep into this. Let's look at the main things that we want to think about: server resources and network resources. And I want to demo deploying a very basic web application that I've made. And where is my mouse? Here we go. The most basic of all web applications for the purpose of our example. One HTML page that says, "Welcome to the new year to all of you." Our goal is to use cloud computing, in this particular case, Amazon Web Services, to deploy this web application such that people can quickly access it. All right, so what's the first thing that we need? We need, well, a server, right? I'm going to go ahead and create one right now. We want to choose an operating system. Let's go with Ubuntu, tried and true. Normally, what would you do when you create a physical server? You want to choose the kind of hardware you want on it, how much RAM you want, how many cores you want. Let's take, for example, a very basic one, 1 GB RAM and 1 core. Let's add a hard disk of 8 GB. We don't need much more. And we need to configure, when I say configure internet connection, if you want to speak in more specific terms, you want to configure our firewalls or our incoming connection and our outgoing connections. So in order to deploy our web application to our server, we'd normally need to have an incoming SSH connection. And since it's a web application, we clearly need to have an HTTP port open as a minimum. Let's just go with this. We have a keep things simple over here. So we're now going to create a server that consists of 1 GB of RAM, 1 core with these ports open, and an 8 GB hard disk running Ubuntu 18. We'll give it a few seconds. And as you can see, gone are the days when you need to actually set up a physical server and take several hours configuring the machine, testing it, installing the OS, and having things ready. This will be ready within seconds.
While it gets ready, Loban, I have a question.
Sure thing.
So you want to talk about like the instance type, what are the other instances available there? And also, do you want to talk about the port 22 that you opened and why?
Okay, sure thing. When we look at the configuration, the instance types, let's open this over here. Normally, when you build a physical machine, there's many different aspects that go to it, right? The kind of processor that you use, which determines its speed, how much RAM you want to give, and how much storage you want to give. These are the 3 basic ones. And so the way most cloud computing services work is rather than giving you access to a physical machine, they create virtual machines and of different sizes and different powers that you can use based on your needs. And the reason why this is useful is because the ones that have less resources cost less. And you can quickly switch between cheaper and simpler ones to more expensive ones that have more resources connected to them. For the purpose of my example, we used a very basic one over here. Actually, we used T2, which is slightly different, but they're all have different forms over here. Now, the SSH port, which I can show over here, if we go to normally, when we would consider, wait, that's the wrong one. Let's just open it directly over here. That's fine.
Yeah, I think just we want to know that what that 22 port SSH does. That's probably is like
okay. All right.
Yeah.
So when we were discussing originally what ways there are to deploy our application, I talked about FTP. What is FTP? Basically, you're connecting remotely to a server and you're uploading the files to it. FTP is now considered a less secure way of doing it, whereas SSH, which stands for Secure Shell, is considered a more secure way to achieve that. Using SSH, you can log into a remote server and you can upload files to it, which I shall demonstrate now. Let's first get our server ready. We're going to go back to Elastic IPs. Sorry, we're going to go back to our instances. As you can see, our server is ready. What's the next thing that we need to do? Normally, we need to have a real IP address connected to this server that we've created. Let's go ahead and do that. I'm going to create an IP address. Well, get one. And I'm going to connect this IP address to the server I have just created. Associate it with my new server. And with that, I have a server ready to go that I can now standard way to SSH to log into a Ubuntu server, as you all know, is with the user Ubuntu. And there I am. A server with 1 GB of RAM and 1 CPU core. All right. What's the next step to deploying our application? We want to copy it, right? So we're going to, and these steps should be familiar to anyone who's ever used an Ubuntu system. I am going to install Apache.
And what you're showing now is the traditional way of doing things, right?
Yes.
Yep.
I'm showing, well, I call this phase 2. The traditional way was doing this on a physical machine, but I'm now doing this in the cloud. But again, I'm doing things manually, and hence this is step 2 in our journey over here. Very simply, I've set up now Apache, and I would now like to deploy my web application to it. So I just need to copy this to my server. And for that, we will make some quick permission changes. The details of this are not so important. Suffice to say, we just need to use SCP, the equivalent of FTP, but in a more secure form. Index.html to my server. Ubuntu. My application is deployed. And so let's access our newly minted server running our web application. All done in 5 minutes.
Woohoo.
Right. Let's go a bit further. Who wants to access our web application with an IP address? We need to have a domain for it. All right. So we just go to another service that AWS provides. I already have a domain that I've bought, and I would like to now make a subdomain that points to my new server. And as anyone who's done a little bit of networking is, you create one. Let's call this demo. We put our IP address. And now that it's set, instead of accessing with this IP address, we can just access it with demo.mydomain. And voila, there it is. I've only shown a few resources that are available here. Yeah, go for it.
Yeah, I can see that there is a HTTPS already there. Is it correct? And how is it working?
This is only using HTTP. That's why we have this. If I was using HTTPS, it would be the secure symbol. That's another thing you can configure. So, but going back to what I was saying, this is just only a couple of resources that are available using AWS. There's so much more, and they're all available at the click of a button using this interactive tool that you're seeing here. Let's go back to presentation right here. So what did we do? We created our hardware. We attached a real IP address to it. We attached a domain name and DNS entries, and we have deployed and hosted our web application, all in the space of a few minutes using cloud resources, using cloud computing. And from that step, we want to go to the next one. What are the disadvantages of what I was doing right now? One good way to look at why, although this looks amazing, there's still some disadvantages here. I still had to do things by hand. Yes, I wasn't physically using my hands to build a server, but I was physically clicking buttons, choosing menu items to create my infrastructure. Let's say I want to now change something. I want to change the name from demo.afterbound.org to something else, like hello.afterbound.org. I have to go into the menu. I have to make a change. What do you do when you want to make changes to your source code? We don't just, we make changes to our source code and then we commit into Git. Why do we do that? Because Git keeps a history of our changes. We are able to track what changes were made when. We're able to go back to a previous snapshot of our code, or we can make different branches to try out different features in our code, combine them together. There's so many advantages we have when maintaining our source code because we use a source code management system. No such thing exists to try and maintain our infrastructure. It's all done by hand. And if there's multiple people touching it, sometimes it's hard to keep track. Wouldn't it be cool if I could maintain my infrastructure the very same way I maintain the source code of my web application? And that comes up to the final phase of this presentation, infrastructure as code. Let's look at another overly complicated definition when you Google it online. What is infrastructure as code? Infrastructure as code is the process of managing and provisioning computer data centers through configuration files rather than physical hardware. Rather than physical hardware configuration or interactive configuration tools. Again, a mouthful. Let's break this down. Physical hardware configuration. This is what we talked about right in the beginning. Server resources and network resources, physically. And what we do to make that better, we replaced it with an interactive configuration tool. That's the web UI you just saw in AWS, where with click of a few buttons and choosing a few menu items, I'm able to create the very same infrastructure that I had to physically do before. But instead of this, now we're going to maintain our infrastructure purely through just a few configuration files, nothing more. Here are the tools that we can do this with. One is called Packer. And with Packer, if we go back to those resources that we talked about right in the beginning and continually visit, Packer is going to help us manage our operating system, the software libraries we need for our web application, and our web application itself, all automatically through a configuration file. And let me show you one example I have made right here. If I can find my mouse cursor. There it is. Now, you can go to the Packer website to learn more about this tool, but instead of going deep into that, let's just directly look at a configuration file so that you can appreciate how simple it is and how it maps directly to what we were doing manually before. What did we do? We chose a particular operating system that we wanted to use. These lines here refer to that. Ubuntu 18.04. I've given it a name. I'm telling it to install Apache and copy my application to it. So this configuration file is has basically taken what I was doing manually and expressed it in the form of code. And how do I run it? It's as simple as, we're going to exit out from our server over here and use the Packer tool, build this example. And what this is going to do is create a virtual machine image in AWS that has exactly what I have configured over here. It'll have Ubuntu with Apache installed and my application installed to it. with one command, it'll be ready to go. And if I want to change the configuration, if I want to upgrade to using, say, Ubuntu 20, I just change my file, I commit to the JIT, and I run my Packer build command again, in the very same way that I would run a build command to build my web application. I would, if it was a Java web application, what would we do? We'd use the Java compiler to build it. Over here, I'm using the Packer tool to build my entire virtual machine in one go. While this is happening, let's look at the next tool. Terraform. With Terraform, we get to build everything else that was in our list. The hardware, the internet connection, the IP address, the domain name, and the DNS entries. As you can see, Terraform is an infrastructure as code software that provides, just like Packer, a command line interface workflow to manage our cloud services. This is an example Terraform file that I've written. And let's take a look. Everything that we did with the AWS UI is now here. Check it out. This is the configuration of my SSH port and my HTTP port. I've configured here the instance that I want to make, the virtual machine with the configuration. I chose small. I've told it to make an IP address and connect it to my machine. I then said to create a new DNS entry. We're going to call this one example for the machine that I have just made. The public IP that I have just created over here. Very, very simple stuff. And we'll go this into more detail at the end of the presentation if people would like to explore this a bit more. But it will suffice to show, how do I build this? Just like we would build our web application, running a build command. The build command in this case is Terraform apply. And I'll say yes. And with that, Terraform is going to create my infrastructure all in one go. It's creating my IP address. It's creating my DNS entry. It's creating my virtual machine. And if we give it about a minute, it'll all be ready. And we can see it happening in real time while it is working. Let's reload this particular page, which shows my DNS entries. You can see it's already created that extra entry over there. Let's go to our IP addresses. There's another one that just got created. Let's go to our instances. It's still creating that one. And as soon as we're done, it'll show up over here. Whoa. This is the problem with live demos. We have a bug. I'll complete that right now. Example AMI. Run it again.
So both can run side by side. I thought the Terraform needs to run first and then the other one should run. Is that a dependency or?
Packer is creating a base image, which then Terraform will use. So I have to run Packer first. And you're right. I mean, this one hadn't finished, which is why it didn't find it. Now it has. Here we go. The new instance that I've created.
So the first one was something that you manually created, and the second one is what just got created?
Yep, this is the one I manually created in the middle part, in the second part of my presentation. And this one has been created using Terraform. In order to differentiate them, you can see I've given names called example for all the new resources, the IP address, the instance, even the security group, which says the different ports that are open. And let's go to our new server called example.afrobun.org. And just like source code, where you want to change a feature, you just change your configuration file here. Hey, I don't want to call this example. Let's give it a good name. Let's call it Hello 2021.
Why not be a Cloud Pro? I think that suits better.
Be a Cloud Pro. Let's put a few dashes in there. I don't want to make this a small instance. My web application is super popular now. Let's make this a large. I will not change this right now, although it will work because I want to not take too long. Let's make a simple change. I want to change my DNS entry. Okay. So if I want to change my DNS entry, I can. What do you do when you change your source code? You can look at a diff of what's changed. This is what's changed. I can commit it to source code, and I can build it. Terraform apply. And Terraform apply will look at my change and will tell me, this is the change you want to do. You want to change your example to be a Cloud Pro. Do you want to make that change? Yes, I do.
So is it a surprising, how does it know that this is the only change? Like when you deploy something on the cloud, there's so many things that it's doing, right? So like so many stuff going on there. So it's kind of have to like diff out the exact thing that it needs to run. So how does it happen?
It keeps, so Terraform is keeping track of what it's doing. Everything you've said here, it knows exactly what it has done to create this resource. I've given them names, right? So it's the question you ask the same question in terms of source code. How does JIT know what lines have changed? Because it knows what it looked like before, and it knows what I want to do now. And it compares them and creates a diff saying, okay, you want to change this line to that line. In the same way, Terraform keeps track of what change you've made in your code and what change then is necessary in the cloud. So when it sees that, okay, I've changed the DNS entry, Terraform understands, all right, I need to find the old DNS entry, which had the previous name, and change it to the new one. And since it's done, we can go straight to our website. This is no longer going to work. We're going to go to be a cloudpro.apple.org. There it is.
Ooh, that's magic.
So let's come back to over here. What have you been doing? We've been talking about deploying a web application. We talked about how normally we would have put it to a physical infrastructure, how we would have set that up and used SSH or FTP to connect to it. We then decided that, you know what, let's make this better. Let's use cloud infrastructure instead, so that instead of having to build physical hardware or change it, with the click of a few buttons in an interactive web application, I'm able to change my infrastructure or create it or destroy it. To this final stage, where infrastructure is no different from the code that we use to write our application. In the same way that we write code to create features in our application, change them and maintain them, we can do the same thing with the infrastructure that is necessary to run our web application. And I'm going to end this by destroying everything I just made with Terraform destroy. A quick yes, and everything that we just built with one command will refresh, will disappear. This one is still there because we made it manually. We'll refresh here. It's still working, but while it's at it, it will remove each one by one. So Just like you can write an application.
We have a question, Loban, for you. Isn't this mostly a one-time thing? This is from Fazrul. Isn't it mostly a one-time thing? When would we need this more frequently?
When would we need to use these tools, you're saying? Okay. You are right. This is not something that I'm not going to be running these commands so regularly. However, consider this. Let's say you need to make a change. Let's say your web application has become popular and you need to change the size of your server, or you need to add more servers. It's the very same thing as when you're maintaining an application. Once an application has become mature, you don't make changes that often to it. But when you do, you follow the same process. You add a certain number of lines to your code, you build it, you deploy it. In the very same way, when you want to change your infrastructure, you change your line of code, you commit it, you build it. Okay. If you are in the business of maintaining infrastructure for many, many applications, for let's say a big company, or you're a provider that is providing hosting services for many, many other clouds, imagine what this increase in speed would do. Instead of having to have multiple people using this UI, changing stuff, keeping track, it's just the same thing as having a source code repository which defines your entire infrastructure. All your servers, your IP addresses, your network configurations, your databases, your database configurations, and so on and so forth. Did that answer your question? And are there any other questions so far?
Yeah, I have a question. So the Packer, is it kind of doing the, is it kind of creating what is it doing actually? So I understand it's builds on the on the top of a base image, but then what happens to the artifact that it just created?
Okay, so in order to talk a little bit more detail about what Packer is, we need to understand what AMIs are. And to understand that, we also need to understand what a virtual machine is. So if you've used any virtual machine software like VirtualBox or VMware, you know that the first thing you have is a virtual hard disk or a virtual storage device, which is basically an image of a hard disk that you have stored. And usually that contains the operating system. And using that, you launch a virtual machine, which is connected to that virtual storage device and boot your device. The equivalent of that on Amazon Web Services is called an AMI. It's an Amazon machine image, which is basically just a virtual storage device that contains an operating system and any software that you've put into it. So when we were first creating an instance and we're choosing an OS, all we're doing is we're choosing a base storage device pre-built with this operating system to start it with.
Do you have Windows there?
Sorry?
Do you have Windows as well? Can we run Windows on the cloud?
You can run Windows as well. You can run Mac OS. You can even run stuff that has an OS and stuff built into it. Like if I search WordPress on AWS, you'll see that they have base images which contain Ubuntu and WordPress already installed. So I could just select this, make an instance, and I have WordPress ready to go. So what Packer is doing is creating my own custom AMI. So for example, this AMI that I have just created using my source code is Ubuntu with Apache installed, with Apache and my application installed. And that AMI is, if you make your AMI public, you can search for it and it'll show up. Right now it's private, so I'll have to go here and I have my own AMI that I've built. So using this AMI, I can then launch as many virtual machines as I want to run my application.
Great. A few more things like use cases that we should use Terraform.
You'd like to know some more use cases?
Yes, please. Before that, I think there is another question from someone, from Faujul again. Would you call Packer? So the question is in the chat, Loban, if you want to take a look. Yeah.
Oh, in the chat. Very good. Let me take a look at it there. I am.
Okay, if you can't get it, I can read it out for you.
Yeah, could you please do that?
Would you call Packer an equivalent Docker image, which is a bit more popular in the industry?
Okay.
Yeah.
Very good question. Thank you. Now, there is a bit of a difference. Docker is not a virtual machine. Docker is a container. Whereas Packer doesn't create containers. Packer creates virtual machines. So Packer creates the equivalent of, say, VMware or VirtualBox images, whereas Docker is creating a container. And what's the main difference between a virtual machine and a container? A virtual machine includes your application as well as your entire operating system, and it's simulating your hardware as it runs it. Whereas a container is much simpler and faster, where it's just your application and the tools that it needs, and it's running on the native OS of the machine that it's running on. So I would say Packer is more like VMware or VirtualBox than Docker. Now, you are right. The Docker is extremely popular right now, and it is a different way of doing things. Instead of creating a virtual machine, you can create a Docker image, and cloud services like AWS and Google Cloud also have the ability to run Docker containers directly. And this is an alternative to that. Why would you pick one over the other? Well, there's different cases. Some applications actually are very difficult to run in a containerized version. And for those, a virtual machine makes more sense.
All right. Any more question from anyone?
Farooq here.
Yep.
So So my question is, in order to write the Terraform script, do we have like any templates or a templates library where I can just copy the security policies and other things?
Yes. If you go to the Terraform website, their documentation is very extensive. They have documentation on all the different configurations that you can do for AWS, for Google Cloud, with many, many examples. In fact, I built this very, very quickly by copy pasting a few simple examples and messing around and changing a few values. So like, for example, there's an example of how to create something with the base image of Red Hat. And I just changed to use Ubuntu. So yes, it is, you can get up and running and have a script working very, very quickly by copy pasting examples.
Thanks.
I have one more question. So that I don't know if it's going to happen for everyone, but at least some people, because if you're working in a team and you're like sharing your Terraform code, like multiple person are like editing that. So I understand that can get into Git and the conflict can be resolved there. But if two persons trying to do the same thing, or maybe changing a script and trying to build, what would happen? It's not like going out of sync.
Very, very good question, Asano. And this has been addressed. So this script is telling me what I want to exist in AWS. So the question to ask before your question is, how does, when I run Terraform apply over here, after making a change, how does it know what the system is before? And Terraform does that by storing this file over here, which keeps track of what the state is in AWS itself. Right now, I destroyed everything, so there's nothing here. There's a backup here. This one, as you can see, is keeping track of everything that it did in AWS. So if you need to have multiple people maintain your infrastructure, this file needs to be shared by everyone. Now, this can be done by including this in the source code as well. So not only do you have the code that expresses how it should look like, but the actual state of the AWS configuration. There's other plugins to actually have this one automatically maintained in AWS itself. So whoever's running it, Terraform will contact AWS S3, a file system, check to see what the state is, and then make changes accordingly. So that way, multiple people can maintain it at the same time as well.
So is this some kind of locking mechanism you're saying?
Yes, it's a locking mechanism. It's a state saving mechanism. So it keeps track of its state.
Thanks, Loban. There is one question from Mustafa. He asks that Terraform platform is completely new to me. What is the learning process of this? Where I can get the material, and do you offer any course about it?
All right, a very, very good question. And I'm glad to hear that you're interested in learning more. My journey in learning Terraform was entirely from the documentation that's provided on their website. It is quite extensive. And in addition to that, they have tutorials, which you can work through using your favorite cloud service provider. If I picked AWS, they have multiple tutorials with timelines and beautiful number of steps telling you the time with videos and so on. So for free, you can go quite far. And there are paid courses available. There are certifications available too. So if you learn, you can actually get a certification for it and put it in your CV, and people recognize that you are certified to use these particular tools. Terraform is quite new, as you can see from this, but it is quite stable, and they have, like other good software, they have a roadmap or when changes are coming, long-term releases, so you know that if you're depending on a particular version, it won't suddenly disappear on you.
Thanks for the question. I have one counter question. Like Terraform, like job-wise, in the global market, can you talk about it? Like, is it really like in the jobs nowadays? Do companies really ask for it?
Companies are not going to ask for Terraform. Some might. Some companies use it. What companies are looking for now are people who are adept in cloud services. And this is not the early day of cloud service anymore. Now, lots and lots of people are there in the market that know how to use AWS, how to use Azure, how to use Google Cloud. So how does someone who is just starting out stand out among them? The best way is to be able to do it faster and better. So if you know how to use Terraform and you are competing with someone else who just knows how to use AWS, you can achieve what that other person achieves much, much more efficiently. You could do by yourself, set up an infrastructure which might require in one day, which might require someone else many days to do. This makes you this makes you more valuable to a company because you're more efficient. So the word Terraform is not going to be in like job requirements, but if you see AWS in a job requirement and you have Terraform as a tool in your belt to help manage AWS services, you can argue that you are more valuable than one who doesn't.
I have a question here. So, for example, for AWS, there's a CloudFormation already available in there, doing the similar things. Mm-hmm. So, Terraform actually, what kind of benefits actually providing compared to CloudFormation?
That's very good. There are a lot of similarities between Terraform and CloudFormation. The very first difference is CloudFormation is only AWS specific. Terraform works with any cloud provider, making And when you have more choices, that means you're more flexible and you can do more things. Also, from my personal, I've used both CloudFormation and Terraform, and I'll have to say that CloudFormation is very, very verbose. I mean, you look at a CloudFormation configuration file, it'll be multiple times the size of the equivalent Terraform.
That's scary. This scary. Don't go there. It's very scary look. Yeah.
Yeah.
Very difficult to read.
It's almost not human readable. CloudFormation was made for machines to read, not for humans to read. Whereas over here, Terraform is very, very human readable, at least to me, and especially if you compare the two.
And also the advantage between the JSON and YAML. YAML is much more readable by design. So, yeah.
Thanks, Loban, for the clarification.
I have one more question. Oh, there's another question from Fajul again. So, what is the cost of using Terraform, personal and enterprise? Are there alternative platforms who provide similar services?
All right. So Terraform is just an open source piece of software. So there is actually no cost to using Terraform. The cost is coming from the cloud service that you're using. So if I use Terraform to create, let's say, an EC2 instance, then the cost of the EC2 instance is what you have to pay for. But Terraform itself is not adding any additional cost. There may be some enterprise versions of Terraform that give you, I don't know, things like other enterprise software gives you, you know, a channel where you can seek help and get 24-hour service and things like that. But in my needs, I have not needed that. I use the open source releases, and their documentation is very high quality. So I have not actually needed to get direct assistance from anyone. That being said, I have to give a warning. This is, again, it's new, so things will change. It is production ready, and this is the time when it's good to jump and learn something new, because it's new technology. If you're able to absorb it, makes you stand out among others.
Yeah, that's for sure, Loban. I have one more question. So I mean, imagine you have a resource that you don't want to destroy. So you can deploy your resources to AWS and you can destroy it, understood. But sometimes we want to keep this state. For example, database, right? I probably want my EC2 instance down, but I don't want my database to be down because that has like important data. So in such a case, is that a way to like tell Terraform to not destroy some of the resources that are important to me?
A wonderful question, Asano, and there are multiple ways to do this. The best way to answer this is to ask the same question for your web application. What do you want to do if in your web application you want to remove code for a feature, but not another one? You'd maybe make a branch.
Yep.
And make a change there. And if you build from that branch will have the feature that you've removed or added. And your master branch is still the same. You could do the same thing over here. Make a branch, remove the stuff that you don't want, keep the stuff that you do, Terraform apply. Or you can create folders. Now over here, I just have one Terraform file, the Terraform example.tf. These things can all be split into different files and folders. And when you run the Terraform command, it loads all files it finds in the current folder. So if you separate them out into different folders, you can pick and choose which ones to turn on and which ones to turn off based on which folder you are in when you run the apply command. So for example, I can put my EC2 instances in one folder and a Terraform file for all my databases into another folder. And that way I can turn each of them off and on separately.
Thanks, Loban. Anyone has any more questions, please? Free to ask.
I'm also open to questions on, it doesn't have to be on Terraform and Packer. If you want to know more about just cloud computing, if you're interested, if you have some questions regarding that, feel free to ask as well.
Okay, what kind of terminal are you using right now?
Me, I'm just
Quite
using
nice.
the default terminal that comes with the Mac. Terminal, it's what it's called, and I use Z shell.
Okay, Z shell.
But I'm running a software called Oh My Zish, which adds all this nice fun
Okay,
stuff.
correct.
So if you're interested in that, you can just Google Oh My Zish to find the extensions I put to my shell.
Okay, actually, I want to add one more thing on the job market of Terraform. So my previous company in iPrice, actually, we are using Terraform, and that's why in the job description of SREs, we added that we want this skill, Terraform, then Ansible as well. And apart from that, on the job market as well, actually, I found that there are a lot of jobs where one of the requirement is Terraform.
Yep. And even if you're absolutely correct. And even if a company that you're in is not using Terraform, you can try and be the one that introduces that to your company, and that would be a valuable thing as well. Infrastructure as code, at least in my personal belief, and in the experience that I've seen, is the next wave of cloud computing. And it won't be just writing configuration files. What's the next stage? It'll be your own application creating its own infrastructure as per necessary.
I just remember one more question. That's about, I'm kind of get confused sometimes, like when to use Terraform and when to use something like, for example, like a basic building tool that runs this command, that logs into the VM and runs a command. So can we
Ansible or something?
Yeah, for example, Ansible. Yeah. So
okay.
Yeah.
Very good question. So let me ponder that question a little bit. Ansible is a provisioning tool. Correct me if I'm wrong, but from what I remember from my experience with Ansible, it's a provisioning tool. You use it to provision infrastructure. So let's say I have a server, I can use Ansible to configure my operating system and the software libraries and the settings in my infrastructure. I don't think you can use Ansible to actually build the infrastructure itself. So it is totally okay to use Terraform to build infrastructure and then Ansible to configure the infrastructure that you've just built and put them all.
Ansible is doing the same thing as Packer, you're saying?
So yes, Ansible and Packer have a lot more in common because Packer is also creating virtual machines and provisioning them. If you actually look at the Packer documentation, you will find that they even have examples of using Packer with Ansible. As well as some other tools. I don't know exactly where they are, but you can combine them together if you prefer. So like, for example, let me show our simple case here. Over here, how did I configure my system? I just ran a couple of lines of shell, right? But instead of this, you could run Ansible with an Ansible configuration to configure this particular server. The main thing Packer is doing is creating a virtual machine image in AWS or whatever other cloud service for you, so that you can use that to create the rest of your infrastructure. Nothing more. So look at this, provisioner type shell. There are provisioner type file is copying a file. There are other provisioners which allow you to use Ansible to provision the machine that you're creating over here. And that would be, you can take a look if you go to guides and look at provisioners. I'm not exactly sure where it is. Here we go. Check it out. These are all the different provisioners available. I just use shell and file, but there's Ansible, there's Chef, there's Puppet, all the stuff that you might want to use.
We have one more question from Fazul. The question is, does Terraform complement GitHub Actions so that I am using them together?
GitHub Actions is very new, and GitHub Actions I've not used GitHub Actions, so please do correct me if I'm wrong, but I understand GitHub Actions is a basic CI tool for continuous integration, or CD tool, continuous deployment. So using GitHub Actions, you can you can like run scripts or do particular actions triggered by Git actions. So you definitely can use them together. So you can say, like, when I commit my code into this particular branch of the repo, run Terraform apply. So that way I can have a repo, for example, that represents my infrastructure. And if I commit, so like, for example, I can set it up. I could set it up such that when I commit a change to my Terraform script to my repo, it will trigger in the build server a Terraform apply command. And it'll automatically change my infrastructure. So I don't actually have to run Terraform apply manually.
I have one question.
Mm-hmm.
Is it possible to use Terraform to discover the infrastructure details from an environment, from a cloud computing environment?
That is a very excellent question. And I unfortunately do not know the answer to that. That would actually be really, really wonderful if I could use Terraform to reverse engineer an existing existing AWS setup. In the same way that, we have an existing database that you have to reverse engineer and represent in ORM, it would be very cool if Terraform could do that, like create a Terraform file based on what's there, and then you can modify it. That is a great question. I do not know the answer. And if it doesn't, that is definitely something that you should suggest on their community forums, because that would be a very, very useful tool.
All right, thank you. And let's say one company that decided to build their infrastructure as a code with the Terraform tool,
Mm-hmm.
but then later, different engineer, they tried to change the infrastructure by their own without the Terraform.
Mm-hmm.
In that case, is there a way that you can again get a hold of the infrastructure through the Terraform?
Okay, this is a great question. Now, a great way to answer, like I said before, this question is ask the same question, but in terms of your web application. We have Git, we make changes, we keep track, but then someone went to production and changed the code directly there. What would you do? You'd have to, the correct way is to prevent that, right? Nobody should be able to go to production and change the application directly without going through Git. In the same way, if you're using Terraform, you should block people directly making changes manually. Now, suppose that still happened. Terraform has a mechanism to notice if what is on the server is not matching what it thinks should be on the server, and it will tell you. And this has happened to me before. And so basically it's like debugging. I'm like, okay, so Terraform is saying, hey, by the way, it was supposed to have 5 EC2 instances, but I only find 3, or I find 7. And then you'd have to go in manually and try to remove that. The best solution is, like I said, to prevent, like if you're going to manage it using Terraform, prevent manual changes. But if that happens, there are some debugging, like it gives off some debugging information for you to help you figure out what happened over there.
Okay. I have one more question that, I mean, if you compare the infrastructure as a code between Terraform and CloudFormation, let's say I have a AWS environment. Which one you will which one is the best? Or for example, if I have an environment, only AWS environment, and I want to configure my infrastructure, then what is the best between Terraform versus CloudFormation template?
Okay, so best is you know how they say beauty is in the eye of the beholder. I mean, best is, there is no best for everyone, right? Different people have different needs. And so what is best for one person may not be best for another. So I can say from my experience and from my needs, I found Terraform to be a lot easier to use than CloudFormation.
Okay.
The documentation for me was really good. It was simpler. Like Asano was saying, like trying to read a CloudFormation file is much harder than reading a Terraform file if you know how to use both.
Right.
So for me, I really like Terraform. And what I really liked about Terraform also is that it supports multiple cloud services. And different cloud services, the names, the variable names, and the resources are different. Like if we look at this file, this is called AWS instance, right? So if I want to make a GCP instance, it's going to be something different. But they try to make the syntax for the different cloud services similar enough that it's easier to learn than having to learn CloudFormation and then the equivalent for Google and the equivalent for Azure, which can be very different from each other.
Okay.
And you can have one Terraform file that handles multiple cloud services. Like I could have an AWS instance and I can have an Azure instance, and I can, deploy my code to both of them.
Okay. My last question. Is it mandatory to do the certification, Hashicorp certification? Like if you want to, for example, if I know Terraform how it works, but is it still mandatory to do the certification, or what do you think?
I don't. Whether it's mandatory or not depends on like the job that you're applying to, right? Like when you apply to a job, if they say they require Terraform certification, then you should get it. If they don't require it and you have it, I mean, this depends on where you're applying for jobs or where you're wanting to work.
Right.
Because it's so new, I haven't really seen many cases of companies requiring certification, at least in my experience. So your mileage may vary. I mean, I encourage you to go look at job posts and stuff and then see. I actually plan to get certification in the near future because, as you know, having a certification adds a little bit of oomph.
Yeah, exactly. I mean,
so it doesn't harm. It doesn't harm you. It's only a good thing to have it, and it's not. I don't think it's a waste to get it either. So you could go for it, but I don't think it's a must.
Right.
I just want to add to it, like in today's market, when you really have to stand out, then having a Terraform certification certainly gives you that boosts. So definitely, I'd encourage everyone to like think about it if you have time. Yeah.
Yeah, I would say don't go for the certification right away. Like learn it, use it a bit.
Yeah, of course.
See if you like it. I mean, if you start doing the certification, you're like, I hate Terraform. Then love it first, and then get certified first.
Right. I totally agree with you. Thank you.
Thank you, and thank you for your great questions.
No problem. Thank you.
Thanks, everyone. Any more questions from anyone? If not, then Noor, would you take over and conclude, please?
Oh, thank you, Loban. It was really nice presentations, and really, I think it will help to our listener. And thank you very much for joining us. Mr. Asan, you also. Thank you very much.
Thank you.
It was really nice presentation. তো এতক্ষণ আমার সঙ্গে যারা ছিলেন তাদেরকে অসংখ্য ধন্যবাদ জানাচ্ছি। অত্যন্ত গুরুত্বপূর্ণ কিছু আলোচনা আমরা শুনলাম লোবান রহমানের কাছ থেকে, সাথে আহসানুল ছিলেন। তো আমি আবারও আমার বাংলাদেশে যারা আছেন তাদের উদ্দেশ্যে বলবো যে ক্লাউড কম্পিউটিং এর উপর এখন সময় এসেছে আমাদের কিছু শেখার। বিএ ক্লাউড প্রো আপনাদের সঙ্গে আছে। আমরা চাই আপনারা ক্লাউড কম্পিউটিং এর উপর আরো কিছু আইটি নলেজ অর্জন করে দেশ বিদেশের বিভিন্ন জায়গায় যে ক্ষেত্রগুলো তৈরি হচ্ছে সেখানে আমাদের দেশ থেকে, বাংলাদেশ থেকে আরো প্রফেশনাল তৈরি হবে, এটি আমাদের প্রত্যাশা। সো আজকের ওয়েবিনার কেমন লাগলো আপনারা আমাদেরকে জানাবেন। আমাদের ওয়েবিনারগুলো যদি ভালো লাগে তাহলে আমাদেরকে জানাবেন, বা আপনাদের কোনো মতামত থাকলে আমাদেরকে জানাতে পারবেন। আমাদেরকে ইমেল করতে পারবেন info@bacloudpro.com। আমাদের ইউটিউব চ্যানেলে আমাদের ওয়েবিনারগুলো থাকবে, আপনারা চাইলে পরে যে কোনো সময় দেখতে পারবেন, এবং আপনারা চাইলে আমাদের এই ওয়েবিনারগুলোকে কারোর কাছে শেয়ার করতে পারবেন, আপনার পরিচিত জন। কারো যদি কিছুটা উপকার আসে, আমরা তাতেই আমাদের সার্থকতা। বিএ ক্লাউড প্রো আপনাদের সঙ্গে সবসময় থাকবে। আপনারা ফলো করুন আমাদেরকে, আমরা নিশ্চয়ই আপনাদেরকে একটা সঠিক দিক নির্দেশনা দিতে পারবো। আজকের এই ওয়েবিনার আপনাদের কিছুটা যদি কাজে এসে থাকে তাহলে সেটাই আমাদের সার্থকতা। সবাই ভালো থাকবেন, সুস্থ থাকবেন, বিএ ক্লাউড প্রোর সঙ্গে থাকবেন। শেষ করছি আজকের ওয়েবিনার। সবাইকে এতক্ষণ আমাদের সঙ্গে যারা ধৈর্য ধরে ছিলেন সবাইকে অসংখ্য ধন্যবাদ। আল্লাহ হাফেজ।
Thanks a lot. Bye-bye.
Bye, everyone.